The second type of trig equation that we want to look at is when you've got multiple trig functions within the same equation. And with this, when it occurs, we want to move all expressions to one side and factor. We did the MAC factoring, we did factoring by grouping, we did factoring on a monomial, all those different things earlier in section 5.1 and 5.2. That's what we're going to need to apply here. So here's an example of solving the following trig equation on the interval from 0 to 2 pi. Notice how this says 0 to 2 pi here, so I don't have to include every single plus 2 pi n. I only want my original solutions. So let's work through this one. Secant of x cosecant of x is equal to the cosecant of x. This is one where we're going to move everything to one side and factor. So the secant of x, cosecant of x, minus the cosecant of x is equal to 0. Now what can I factor out from there? And if you look at it, you can see, okay, I can pull out a cosecant from both. So the cosecant of x, then I'm left with secant of x minus 1. And since I've got two pieces that are being multiplied together, I can apply the zero product property that says each piece individually has to be equal to 0. And then I'll go about and solve. So here we'll go cosecant of x is equal to 0. We'll take the cosecant inverse to both sides. Oops, need my little cosecant inverse there. So x is equal to the cosecant inverse of 0. And then over here we've got to add 1 to both sides. And then we'll take the secant inverse to both sides. Secant inverse. Now the issue we're going to run into is that cosecant and secant don't have buttons on the calculator. So I need to rewrite these with their reciprocals. So the first part right here, cosecant inverse of 0, we can put that as 0 over 1. That's the same thing as 0. And the secant inverse of 1 is the same thing as 1 over 1. I only have sine, cosine, and tangent on my calculator, so I need to rewrite these guys in terms of sine, cosine, and tangent. So right here, the cosecant inverse of 0 over 1. Cosecant is the same thing as 1 over sine, so it's going to be the sine inverse of 1 over 0. I've got to flip my pieces that are inside the parentheses, because cosecant is originally hypotenuse over opposite, and then sine is opposite over hypotenuse, so I've got to reverse those two pieces. Down here, secant is related to the cosine, so really we're looking at the cosine of flipping 1 and 1, which is nice because it's just 1. Once I do this, I can see sine inverse of 1 over 0. That's not going to produce anything. 1 over 0 is undefined, and if I plug that into my calculator, I'm not going to get anything. And then here, the cosine inverse of 1 over 1. And this one's once again on the interval from 0 to 2 pi. So I've got to make sure I'm in radian mode, which I am. So the cosine inverse of 1 is going to be 0. So for this one, x is going to be 0 pi. So I only get one solution for this problem. One mistake that I see students make here, and this would be under my red flags of being bad, is dividing by cosecant on the first step. Secant of x, cosecant of x is equal to the cosecant of x. Let's say I were to have worked this out by dividing both sides by cosecant of x and canceling. I would get the secant of x is equal to 1, which is only this piece over here. I lose this whole portion of the equation. Now in this particular equation, it's not that big of a deal because cosecant, when I change it to 1 over sine, is going to be undefined. But let's say I gave something that was going to be defined. Let's say if I did cosines and I take 1 over a cosine, that's still going to be defined unless, of course, I have my zero solution. But I just can't eliminate things on both sides of the equation. I would lose this whole portion of my problem. So that's why I move the cosecant to the other side and I factor everything out.